Good evening, millennials. Today, we'll look at another easy lead code problem often asked in the initial rounds of the FAANG interview companies. So, this is the 349th question in the lead code website. It is called the intersection of two arrays. So, let's read the question and think of the shortest approach to write code. And let's try to write the best code possible. So given two integer arrays nums1 and nums2, return an array of their intersection. Okay, each element in the result must be unique and you may return the result in any order. So for example, if nums contains these and nums2 contain 2 and 2 and nums1 contain 1, 2, 2 and 1, the intersection is 2, only 2. Even though it repeats twice, you have to return an unique array. Similarly, if nums1 is 4, 9, 5 and if it's 9, 4, 9, 8, 4, you should return only 9 and 4. Also 4 and 9 is accepted. Remember that you have to return only the unique one and it can be in any order. So let's look at the constraints. So nums1 length and nums2's length is 1000 and each element in each of the arrays is between 0 and 1000. Since it's between 1 and 1000, you can think that you can write an n square or an n cube algorithm. But that may be accepted in lead code, but that won't be accepted in a professional interview. So let's think of this unique solution. So you don't need to actually know how many numbers are there in each of the arrays. You just need to know if the number exists or not. So what you can do is you can create a map of each of the elements and you can just check whether this first element whether the elements in the second array exist in the map or not. If it exists in the map, just add it to a vector. But here, instead of vector, you need to first add it to a set because you need to return the unique ones. So just add it to a set, and that because set can only contain unique elements, and at last return the vector of the set. Remember that to form a set you need an n log n algorithm. So the runtime of the algorithm will be n, but for the formation of the set it will be n log n, as set is implemented as a balanced binary search tree. So let's just do that. So first I create a set. So set int s, and then I create a map int m. So now I just loop in through the first array for auto num colon nums. You can do is of num plus plus. I'm just increasing the count of the array, and then I loop through the second array for auto num colon, so it should be nums1 because in the function definition it's given as nums1. Now I'm looping through the second nums2 array, and here I just check whether the element is there in the map we previously existed or not. If mm.find of num not equal to mm.end, which means that we have found the pointer to that element, then I just insert it into the set s.insert of num. At last we have a set, but we need to return a vector as it's the required type. So I just convert this vector into a set. So I just convert this set into a vector. So vector int answer of s.begin and s.end, and I just return answer. So this vector will contain the set. So let's see whether we can make it any better. So if you think about it, we don't actually need to find the count of this nums. Okay, let's just submit it. I've submitted a few times to make sure that I submit the best possible answer, and yeah, as you can see, it passes. But to make it even better, we don't need the count of the numbers, we just need to know whether it exists or not. So what you can do is, instead of an int comma int, you just create an key as int and val as bool. I'm just trying it for the first time now, so I'm not sure if it will pass or not. So whenever it exists, you just put it as true, And now when you check for it, you just check whether it exists or not. So let me just run the code. So yeah, it's accepted. And as you can see, it's much faster, and we have used lesser memory than an int. These small things get you brownie points in an interview. Thank you. If you like our video and you have some more suggestions, please leave it down in the comment below, and like, comment and subscribe. Thank you.